is areas of circles and sectors. Okay. A lot of you, most of you, should already know this first theorem, area of a circle, because you have used it before. Who can tell me how to find the area of a circle? Vincent? Good. Area equals pi radius squared. Pi r squared. Okay. You do have to be careful because there's a lot of times this is confused with 2 pi r. What is 2 pi r? Circumference. Okay, so don't get 2 pi r and pi r squared confused with each other, please. Okay, try to keep those separate. The easiest way that I've found to distinguish between the two is area is always units squared, right? So that's how I like to think about it. If it's area, something has to be getting squared. Okay? So if I give you a circle with a radius of 3 inches, can we find the area? How, Travis? Yep, just plug it into the equation. So I have 9 pi label squared. Good. Okay, it is area, so you do need to make sure to have units squared, whatever that unit may be. Make sure you have units squared. We are, again, going to try to avoid decimals as much as possible. Okay? So we want to keep things in terms of pi if possible. With this lesson, there are times where that gets a little bit challenging, but I still want you to give that a try. Okay? I want you to be able to do that and do the algebra to leave that as an exact answer and not in decimal form. Okay? Next example. They tell me that the area equals 96 centimeters squared. They want to know what's the diameter. Is there any current relationship that we know between area and diameter? No, there's not. But we do know a relationship between area and radius, right? So in a circle, area equals pi r squared. So in this case, my equation would say what? Do I already know my area? So instead of area equals pi r squared, it's going to be 96 equals pi r squared. Now I did have a question last class period. They said, well, but then there's 2 variables. Is there 2 variables? No, this looks like a variable, that pi, but it's not, right? That's just a number. Everybody agree with that? Taylor Stokes, you with us? This is a number. It's 3.14159 continued. Okay? So, to get r, my radius, what do I need to do? Divide by pi first. So now I have that r squared equals 96 divided by pi. And then what? Then square root. So now I have r equals the square root of 96 over pi. Now, that can actually be reduced and changed a little bit. For the sake of what we're doing right now, I'm going to tell you to go ahead and leave this. You're not going to have a lot of problems where you do this, so I'm not real worried about it. Okay, but leave this. This is okay. Okay, next year in Algebra 2, I'll show you how to reduce that. Okay? Now, is that the diameter like we wanted, though? No. What do I want to do to get the diameter? Multiply it by 2. So what's my answer going to look like? How do I multiply the square root of something by 2? What if I just had this? What if I just had the square root of 7 and I wanted to multiply it by 2? That'd just be 2 square roots of 7, right? It'd be like this. So what's this one going to be? 2 square roots of 96 over pi. Good. And that would be my diameter. Okay, like I said, you're not going to face a lot of problems like that, so don't worry about reducing 96 over pi under a radical. Okay, it is possible. We'll do that next year. Okay, but for the sake of what we're working on right now, just understand how and what process you need to go through. Okay. Questions on area of a circle. Okay. The next new thing that we have, and the only real new term that you have, is talking about a sector. We don't know what a sector is yet. Okay. So when I have a circle with a distinct arc here, previously, as in not yesterday's worksheet, but the day before and the day before that, we found arc length, right? You guys remember that? We found out how long is that arc, how many inches, centimeters, whatever, okay, using the proportion on the right side of the board, right? Okay. Today, we are going to find not the length of this, but since we're talking about area of a circle, we are going to find the area of this sector. Basically, it's a piece out of the pie, right? Is the easiest way to think about that. It's a chunk out of the pie. How many square units are in that chunk of pie that we took out? Okay, so that's what we're going to be finding today. So that's actually your last theorem that we have for today, is called area of a sector. Sure. Cheesecake pie? Just cheesecake? Any cheesecake sounds good. Any pie sounds good. Now you're making me hungry, Matthias. All right. Area of a sector. We're going to set up another proportion just like we did in the other one, because they're pretty similar what we're finding, right? So it's going to be the area of a sector divided by the area of the circle, which is, how do you find area of a circle? Pi r squared equals the measure of the arc divided by 360 degrees. So you see the similarity between the two proportions, right? Basically, they're the same thing, except in this one over here, we're finding arc length, which is a portion of the circumference, and we're dividing it by the circumference. Over here, we're finding area of a sector, and we're dividing it by area of a circle. Okay, but the right side's the same on both, right? Okay. That's nice, and it's not nice. It's nice because you should have a good idea of what the proportion looks like every single time. Why is it not nice? Yeah, you mix them up. Okay. Now, obviously, on today's lesson, you're not going to use that over there on the board because we're doing area of a sector today, right? You're going to mix this up, and it might be a little more confusing when you do the chapter review, when you take the chapter test. That's when it's confusing. Why? Because they mix them both in, right? Okay, so that's when you got to be careful. It's not going to be confusing right now because you know what you're doing. it's going to be confusing when you get to the review and the test because they're not going to tell you which one to use. You're going to have to know which one to use. So just understand, are you finding area of a sector or are you finding arc length? And that'll tell you whether the bottom needs to be pi r squared or 2 pi r. Thank you. Wrong, Taylor? We got 3 of them. Okay. Questions on that? We'll do 2 examples using that. Actually, we're only going to do 1 example using that, sorry. But we have 2 examples left. All right, the example for that one. I have my circle. This is 11 meters. We are trying to find the area of this sector, and this arc, or this angle measure right here, the central angle, is 135 degrees. That way we can see it a little bit better. Yes? Okay. Royal, do you think you can set up our proportion?
Yes.
You start that for us.
Okay, x over pi.
Okay, so you did pi times 11 squared, right? Which you knew was 121, so you have 121 pi, like you said, equals 135 over 360. Now, this actually brings us to another thing we talked about in the last classes. Some of these fractions over here reduce, but they kind of get to be a pain in the butt, right? You guys know what I'm talking about? Like the ones that reduce to like 6 over 9 or something like that. Okay, those are kind of a pain in the butt. You guys remember when I showed you how to change a decimal to a fraction on your calculator? I'll take that as a no. Don't you remember when, but not how. Okay. At least you remember when. So, on your calculator, take 135 divided by 360. And hit enter. What do you get? 0.375. Now, on your calculators, you should have something that looks like this. That means to change a fraction to a decimal or a decimal to a fraction. So you can go, you're probably going to have to hit second to get there. Okay? But then you can hit that. What's it change it to? 3/8. Okay? So what does this side reduce to? 3/8. That's a little bit easier than trying to reduce by hand, right? Okay, now your other option is you also have a button. It's like a ABC button. It looks like a fraction. You could also use that one. So you could type in 135, hit that button. It gives you a symbol like this. I think it's like that. Do I have it backwards? And then 360, and then hit enter. What's it give you? 3/8. Okay? So your calculator is really smart. There's a lot of things you can do on it. You can reduce your fractions for yourself. Okay, so take advantage of that. Now, sometimes it's going to be obvious. You're going to know some of them. 90 over 360 is a fourth. 180 over 360 is a half. 45 over 360 is an eighth. We just did that one the other day. Okay. So now that I have my fraction reduced, I can do what now? Cross multiply. So 8 times x is 8x. 121 times pi times 3 is 363 pi. Now I divide by 8. X equals, now this is where the other way you can use this. I don't know, does 363 over 8 reduce? I don't know. But if you take 363 and divide it by 8 in your calculator, and then change it to a fraction, okay, what do you actually get when you change it to a fraction? So you get 45 and 3/8, right? You should also have a button on your calculator. It's your fraction button, your ABC button, do second that button, and that's going to change it back to a mixed number as this. Do you guys following all the buttons we're talking about here? So there's a lot of stuff you can do on your calculator to change things back and forth from fractions to decimals. Did you find it?
Yeah, we could have used this before.
Oh yeah, you could use this a lot.
Wow.
Okay? So, does this reduce? No. So my final answer is 363 pi over 8, label, meters squared, because I did find area. Okay. If you have more questions about those type of fraction things on your calculator, let me know. There's a lot of stuff you can do with some of those buttons. Okay. Questions on that example? Do your best to leave it as an exact answer, no decimals. We're going to try to do that. All right. The last example I have for you guys is a hexagon inscribed in a circle and they have a radius of 5 inches. We want to know what is the area of the blue shaded region. Before we actually start solving this, Carly, could you just explain the process of what we're going to have to do? Okay, not sure. Taylor?
Well, you find the area of the circle, and then you can find the area of the hexagon, and then
Good. Does that make sense, Carly? Okay, so what we're going to do is we're going to find the area of the whole circle. Then we're going to find the area of the hexagon. And then we're going to take the circle minus the hexagon. And that should leave us with just the blue portion, right? Okay, so let's find the area of the circle first, because that should be the easy one. Area of a circle is what? Pi r squared. So it's pi 5 squared, which gives me 25 pi. Okay. Now comes a little bit more challenging part, which is actually why I gave you that extra worksheet yesterday to make sure we knew how to do this. That's where it's not going away yet. I got to find the area of the hexagon. What's step 1? Travis? Okay, after I'm going to split this, right? Okay, so I find the central angle. How? 360 divided by 6, which gives me 60. And then I want to split it. So I actually want to use, 30 degrees. Okay. Taylor Stokes. How do I find the base? There's a 30-60 theorem. Yep.
No, not that theorem.
Okay.
Like, isn't that an equilateral triangle? 'Cause the
I
angle
don't know. Is it?
It is an equilateral.
It is an equilateral triangle. So that's actually something that nobody's brought up today. This is 5, right? Has to be because it's a radius. This whole angle is 60. The only problem is you can't necessarily, well, yeah, because if this is if this is 90, 30, then this one has to be 60, which means this one has to be 60. So you do have an equilateral triangle here, right? Okay, that's one option. Okay, so you can do that. I'm going to backtrack out of that and say let's not do that just so we can do it on every problem, because that's not going to work on every problem. That only works in a hexagon. Okay, but you're right. Use that if you want to. What's another way I can find the base, Royal?
Sine 30
I could do the sine of 30 equals x over 5. Another way, you could use your 30-60 special right triangle, which we did a whole few lessons on, so we might know that. So here, what do I end up getting? I get 2.5. So this is 2.5, right? Do I actually care about that little piece? No, I really want the whole base, right? Which is 5. So this whole thing is 5. Vincent, how do I find the height? The apothem, yeah. How do I find it? I got to use another trig function. It's not. I'm going to use cosine. I guess you could use tangent. The problem is if you would have got the other side wrong, then it would give you another wrong answer. So I'm going to try not to use it. So because cosine is adjacent over hypotenuse, right? So cosine of 30 is x over 5. And I get 4.33 is my height. Lainey, now what? I have my base and my height of my triangle.
Yes.
What do I need to do next?
Now you can find the area.
How?
You do. Oh, you don't like the A. It's.
How do I find the area of a triangle?
Yeah. Is it not 1/2 apothem equals? Yeah, you don't like that.
Are you using the theorem?
Yeah.
Okay, what's the theorem?
It's
1/2 the apothem times.
times. Is it the oh?
The perimeter.
Then that's not what we do.
That's not what I like to do. Do most of you do it the way I do it, or the theorem? The way most of you do it, the way I do it. So McKenna, what's the next thing we need to do? So you're doing what? You're finding the area of the triangle, right? The area of a triangle is 1/2 base times height. So you take 5 times 4.33 divided by 2. Now you get the same answer if you use the theorem that we were just talking about, right? Okay. So the area of this triangle is what? Travis? Same thing. Yeah, same idea. What'd you get? Okay, so the area of my one triangle is 10.825. But how many of those do I have? I have 6. So times 6. So the area of my hexagon is what? And I need to take the area of my circle, subtract the area of my hexagon, and I get 0.59 or 0.6 or label? Inches squared, because that was area. Okay. Now, that one, we got this as an answer, right? So if you don't change it all to decimals, that comes back to what we talked about the other day. You're halfway in, you're halfway out. Okay, so if you want to change that all to decimals, I'm okay with that. Okay, but if possible, and on times like just the circles, if it's just a circle, try to leave that in terms of pi. Okay, now, I did have questions last class and actually first period also. How do you type that into the calculator and know for sure that it's doing what you want to do? Because you guys remember the other day when you didn't use parentheses, it messed up, right? You guys know what I'm talking about? Okay, so when I typed this in my calculator, I typed in that exactly. I didn't use any parentheses. Okay? The reason I didn't is because I know my order of operations, right? Parentheses, exponents, multiplication, division, addition, subtraction. Your calculator knows that also, just like we talked about the other day. So when it does this, what's it going to do first? It's going to multiply first. And then it's going to subtract. Okay? The other day, we did multiplication and then division, but we actually wanted to multiply first, but that's not how we typed it in our calculator. You have to be careful. Okay? You know your order of operations, so does your calculator. They know it just like you. If you want to be 100% certain that you never mess it up, what can you do? You can put parentheses around your 25 pi. If you do that, it will never mess it up, because what's the first thing in order of operations? Parentheses. So it'll do these parentheses first. Okay, you do have to just be careful and understand the calculator knows order of operations, but it doesn't read your mind. Okay, so if you want to divide something first, then it better be first. If you want to multiply something first, it better be first. Okay, otherwise it's just going to multiply and then go from there. Okay. Questions on anything from today? We're only going to do half of the lesson today, and then I'll give you an add-on on Monday. Monday's going to be a little bit more challenging problems. Okay, a lot of people have finished today's in class, so hopefully you can at least come close and you won't have much homework over the weekend.